All right. Your last homework assignment is posted, and it's due Friday of this week. We're going to do an in-class exercise today that addresses the first part of that assignment, and then we'll have another in-class exercise on Wednesday of this week that will help you to solve the second part of that assignment. So it's got some questions related to moving the trash to the landfill, and then some questions about the landfill itself. You know, we're moving into solid waste management. We get all the most glorious and really glitzy topics in environmental engineering. We've talked about sewage, we've talked about dirty air, or we talked about noise, solid waste, hazardous waste. It's all this awful stuff that if we don't handle it, nobody else is going to. And civil engineers are kind of tasked with providing the foundation for a civilization. And if we don't deal with our solid waste, then pestilence follows and diseases. And so it's important stuff, but it's not going to win any beauty contests, that's for sure. So homework 14 is due Friday before class, and also Friday in class we'll have quiz number 6. I've got quiz 5 I'm going to return to you today as you're working on the in-class exercise. We've just gone over the presentation dates and some information about the presentations, and then because of Friday of last week's class cancellation, that's just going to limit our discussion of hazardous waste to a single class meeting. So I've canceled homework 15. So homework 14, which you do this Friday, will be your last assignment. So any questions related to the announcements? All right. So unfortunately, litter is something that we see on a daily basis. Whether you're driving behind somebody who flicks a cigarette out the window, or if you're driving on a rural road, I notice that the trash seems to be heaviest when you're out of view of a house. And I don't know if that's just exclusively because like the trash in front of houses gets picked up by the people who live there, or if people kind of subliminally know they shouldn't be littering, and so they wait until they're out of view of other people to do that thing that they know is like socially unacceptable, and they're littering. But whatever the case may be, it's more than just an eyesore. Litter is actually in and itself an environmental problem. Having trash by the side of the road may seem that it's just, you know, kind of gross and unsightly, but it actually has environmentally related side effects. So by environmentally, we're talking about like a permanent reduction in the beneficial use of the land, sea, air, and an impact on the natural species that live in the area. And so some of the effects of litter on the ground is that the substances may be toxic, and those are getting released to the environment. So a cigarette butt, for example. You know, smoking isn't great for you, but some of the pollutants that get trapped into a filter, if someone flicks the cigarette butt out the window, those pollutants can get into the environment. And so that includes things like arsenic, believe it or not, in the filters. Formaldehyde accumulates in the filters. And although it's low quantities, a lot of cigarette butts combined with a little bit of water could form toxic chemicals that we wouldn't want to just be free floating in the environment. So other things may break down because of repeated sun exposure. So plastic, which maybe is inert if it's not exposed to light for weeks and weeks on end, could break down and turn into small little pieces. And the microplastics sometimes can be harmful because they're very small size, makes their surface area large, and they are generally unreactive when they're together as a big piece of plastic. But if they get into your stomach, which is an acidic environment, then those plastics can cause a whole array of health problems. They're starting to find it as an emerging pollutant that people are really worried about. Obviously, it affects the aquatic species where plastic and trash gets into rivers and streams. It can have an impact on fish, frogs, and anything else that either ingests it or is trapped in like a six-pack rings. You've probably seen pictures of fish or birds that get kind of like tangled up in leftover garbage. And this is an old video that I think everybody's probably seen, like the turtle that had the big straw pulled out of its nose, and that kind of made a lot of people want to start using disposable straws. So from the perspective of engineering impacts, the debris from litter can also clog pipes and impede drainage. So old tires or like basketballs, old clothing, all that stuff could get into a culvert, cause the culvert to become clogged, and then water's now overflowing. And so it seems kind of far-fetched at first, but litter actually can cause safety problems. If the drainage that's supposed to occur in a ditch is clogged because of an accumulation of trash, especially if there's a grate, you know, like some sort of a cover on a culvert that's meant to screen out, like to prevent animals from getting in there, or to prevent big sticks and twigs from getting into the culvert. Well, trash can get accumulating in the front side of covers like that. And so if water's flowing over the top of the culvert, it could cause damage to the roadway. It could cause pooling of water, which is dangerous for cars that are driving past. And so for all of those reasons, we just rather that trash not be floating around in the environment. It's better if we gather it together and dispose of it in a sanitary way that's kind of consistent with best practices in environmental protection. So the first question when we are doing the engineering work of solid waste is, how much is there going to be? And there's a range of how much solid waste people generate on a daily basis. Here in the United States, we kind of are known for generating a lot of trash. The United States generates a lot of solid waste. A lot of the Gulf countries in the Middle East, which are pretty consumerist societies like ours, they also generate a lot of solid waste. And then at the other end of the spectrum, societies that are really rural, like developing countries in Africa, or countries that really emphasize recycling, so like Western Europe, would have lower solid waste generation. Places where they sort recycling, and then they're just in the habit of using like fabric shopping bags rather than disposable plastic bags. And like when you travel abroad, you sometimes notice that paper towels aren't the same thing like they are here in the US. You know, like the idea of having a paper towel to wipe down the counter is just absurd to people in a lot of countries where they just use a reusable cloth towel, and so they generate less waste when that's the case. So what this figure illustrates is for the population of a city, what would be, here on the vertical axis, the amount of waste that's being generated per day. And this figure is in SI units. So you can see the midpoint of solid waste generation on a per capita basis is 2 kilograms per person per day. And they say that usually it varies from 1.5 to 2.5 kilograms per person per day. And then, you know, at the low end of that, you may have as low as 1 kilogram per person per day and as high as 3. So probably you wouldn't have guessed that you generate 4.5 pounds of solid waste per day. Like if you think about the things that you're throwing away, you know, it would be maybe banana peels or Amazon box or cans from the food that you're making in tonight's dinner. Just the thing that brings the averages up are one-time things that you throw out that are very bulky or very heavy. So like a used mattress or a couch. Or it could be yard clippings where, you know, seasonally you may have a huge variation in the amount of trash and solid waste that you're generating. If some people, instead of just disposing of the clippings on the grass itself by mulching or, you know, dumping it into a pile at the side of the yard, some people will put it into the trash, and then that adds a lot of organic load to the waste that's being generated. So the way that you could use this figure is you'd go up from like 100,000 people who are each generating 2 kilograms per person per day, and that means that you're generating 200 megagrams per day, where a megagram is 1,000 kilograms, or in other words, that's a metric ton. So 200 metric tons per day would come from 100,000 people generating 2 kilograms per person per day. And then these other figures are just in terms of per week or gigagrams per year, where a gigagram is 1,000,000 kilograms. So the amount varies, and from problem solving, you'd usually just be given some assumption. Assume that the people in your town generate X kilograms or pounds per day. But what can influence that is how closely people are adhering to what's known as the waste management hierarchy. And this is something that comes off of the EPA website, just a mindset of what's the best thing that we could do for the environment and for society when we're faced with managing solid waste. And the best thing that we could do would be to reduce the amount of things we use that generate waste. So for example, sometimes you'll order from Amazon and it'll just come in a very thin plastic bag instead of a big bulky cardboard box. I think they're starting to make more of an effort to minimize the amount of packaging that goes into shipping their materials. And sometimes they even have what they call frustration-free packaging. And that's where in the past maybe it would be common to have like a big bulky, hard to open plastic blister casing, as they call it, for things like batteries or electronic items. Now they're just sealing it up in a very thin, minimalist paper or cardboard coating that doesn't have as much packaging on it. It weighs less. So the best thing to do is just minimize the amount of waste that is being generated to begin with. And this should sound a lot like the mindset that we brought into pre-treatment for wastewater. The best thing that we can do is reduce the amount of water that's going to the treatment plant to reduce the occurrence of problematic chemicals that may interfere with the treatment process. It's cheaper to prevent the problem than it is to deal with the problem once it's been created. And so this is just saying try and reuse things even before you recycle them. Reuse means that you're not having to melt it down to its core elements and then like recast it before you use it again. So reuse could be, instead of just throwing away clothing items that could be repaired, repairing them. Or reuse could be trying to keep a car into service longer than otherwise it would through repairing it, or finding somebody else who's interested in using it when maybe it's beyond the useful life that you'd consider usable. So the next thing after that is recycling and composting. Recycling for like metals, paper, and plastic that can be melted down, ground up, and used as packaging or raw materials again in the future. Composting for things like yard clippings, organic materials, leftover food waste. So if you think food waste is, believe it or not, a shockingly high percentage of solid waste that gets landfilled. And increased efforts have been made to try and, number one, like take food that's on the verge of expiring and giving it to like soup kitchens, food pantries, community giveaways, food that's within a week or two of expiring, trying to make use of that for people. And then if it is expired but not completely spoiled, they're trying maybe to feed it to animals. And then maybe as like a third ranked option would be doing things like trying to recover the nutrients and organic material in leftover food through composting. And then again, even another possibility would be trying to turn that stuff into energy. So instead of like recycling paper, you could burn the paper and then you'd get the energy. You'd at least get something out of it. Now, there's a lot more value in paper that is recycled than burned. Because to generate the paper, you have to, if you think about, you're cutting down trees, grinding them up, bleaching them, moving them from place to place. And so just burning the paper and at least getting the energy out of it, you're maybe capturing 5 or 10% of the embodied value in that material. Whereas if you recycle it, you're capturing a greater percentage of the embodied value. And the same thing is true of organic materials like yard clippings, that you can recover energy from yard clippings actually. They have gas collection systems in some landfills where landfills, the buried garbage that we seal off with a plastic layer on top. They can take the methane out of those and use the methane to either generate electricity or generate heat for the buildings near a landfill. Both of those have been applied in various places. So all of those are preferred before we simply just throw something away and have no further use for it. So treatment and disposal, you can see, is at the bottom of this list of options. And hopefully the areas, the relative areas here, indicate the amounts of each of these. And it's just qualitative. It's not like an actual true percentage, but it's better off if we have a small amount of things that are being disposed of, and most of the waste that we would otherwise be landfilling can be prevented through just using less packaging, reusing items that aren't completely destroyed yet, and so on. So this is how things are going. The United States is a bigger country now than it was in the 1960s. You know, every year our population has been going up so far. Because the number of people has been going up, the amount of solid waste being generated has been going up. But it is slowing. Like, the population of the United States in 2018 was a lot higher than you might expect, just based on, you know, the relative magnitude of this municipal solid waste that's being generated. But this figure also shows how much of it is going where. So recycling gained popularity over the years. Composting has gained popularity. Combustion, but still landfilling is the majority of where the solid waste is going. Because it's easiest. You know, I don't like to sort recycling. And it's actually, they don't do recycling where I live. Some cities have it. I live in a rural area. There's no recycling. So if you want to do recycling, they don't come to your house. You have to track somebody down who will take it. And it's getting increasingly difficult. We'll talk about that in a minute. But, you know, metal has the most residual value out of all the things that can be recycled. And it's still relatively easy to recycle metal. But the other things, you kind of have to almost fight your way into the recycling center to get rid of them. We sometimes use garbage, trash, solid waste. We sometimes use all those words interchangeably, but they don't mean the same thing. There are technical definitions. So for example, garbage is talking about things that can break down because it's putrescible. That means it's organic. It can rot. So garbage tends to have higher moisture content because it's organic in nature. And garbage is maybe the most dangerous if we leave it uncollected, because it's going to attract rodents and other vectors that carry diseases. So cockroaches, mice and so on, rats, so stray dogs. We want to keep all of those things, we don't want them to be spreading disease, and so that's garbage. Trash, on the other hand, is the technical definition for things that are non-putrescible, meaning that they're not going to rot. And so they may be combustible, like paper, cardboard, plastic, all that stuff can burn. And some of it originated from organic sources. You know, paper comes from trees, cardboard comes from trees, but they're not going to break down and rot in the same way that garbage does. So it's got a lot less moisture content, and it's higher in energy. So it's more attractive from a standpoint of energy recovery and less attractive to rodents and other vectors because it doesn't have calories. It can't sustain them in the same way that garbage can. Yard waste is biodegradable, but we wouldn't consider it having originated as food. So yard clippings, brush, trees, branches, and so on. And a lot of cities have implemented ordinances that make it illegal to mix yard waste in with your regular trash. So some places will have a separate, like, green trash can that comes on a different day where they're collecting the yard waste and trying to make mulch out of it. But that is a big component of what gets into landfills, regardless of what the policies are. Some people still inevitably will put yard waste in with what's being collected. Rubbish refers to oversized objects, you know, the things that you're maybe not throwing away on a daily basis or a weekly basis, like leftover washing machines, old TVs. You remember like the big screen TVs? Do you remember sometimes you drive around and just find them by the side of the road, like the old ones? You know, before we had nice LCDs, they were pretty wide, and just TVs would magically appear by the side of the road. And so that's rubbish. And then there are some special categories like construction waste or demolition waste. Oftentimes has to go to a separate landfill, separate from municipal waste, because the rebar, for example, that's in concrete could very easily puncture through the liner in a standard municipal landfill. And that would be really horrible, because collecting the leachate or the liquids from a landfill is a really important part of keeping the environment contained. And so typically construction waste has much thicker clay layers and protection against the landfill being damaged from just the sharp, kind of rugged nature of building materials that have been demolished. And then there are special categories of waste that don't go into either construction landfills or sanitary landfills. Things that, for example, like asbestos, are known carcinogens. They have to be disposed of separately. Or hospital materials that are like human tissues or blood are generally incinerated rather than thrown out with just ordinary garbage. And then like agricultural and mining residues, coal production residues, sometimes it's possible to mix those in with concrete. Sometimes it's possible to mix those minerals in with like other paving materials, but they just can have heavy metal constituents that makes it important to give them special care and consideration and separate it from the kind of more tame municipal landfill. So here's a breakdown that shows the relative percentages of different categories of municipal solid waste. So in 2018, which was the most recent date that I could find data for, in the United States we generated about 300 million tons. And like numbers sometimes just don't mean anything. A ton is a lot, right? Like a ton would crush you. This is 300 million tons. So there's about 300 million people in the United States, approximately. And so I guess that what that means is that we generated about a ton per person in the United States. And then you see that a lot of this is stuff that could be reduced and kept out of a landfill. So the metals generally should be recyclable, especially, you know, steel, aluminum, all that can be recycled. Glass doesn't have a lot of recycling value. You know, it's just basically sand that's been melted. And so to make fresh glass isn't that much more expensive than recycling the glass. I mean, all it saves you is the transportation cost of taking the sand from one place to the other. But like food waste, for example, we could just maybe try and manage inventory in grocery stores better, and we could do a better job about donating food and just preventing it from getting into the solid waste pile that's going to the landfill. The same thing is true of yard trimmings. Like those things could, in theory, be turned into compost. And so the types of things that you can compost would be like putrescible materials that have like an organic component, but then some of them are generally not considered great for composting, because people expect there to be like that it's free of building materials. So like old nails or bricks or something. You know, somebody would be sad if they'd gone and bought compost from the community composting center, and then they're spreading it out over their garden, and then there's, you know, like bones, fish bones in there, or components of trash bags. And so this guide just kind of gives you an idea of the types of things that are beneficial to compost and there's always going to be things that get into the landfill, and it's not a huge environmental problem. We have plenty of area in the United States for landfills as long as the waste is contained correctly. So somebody with quantitative skills and like analytical abilities needs to be involved in the process of collecting the waste and sorting it and disposing of it. And so, we need an engineer, for example, to plan the route so that it's most efficient. Like if the drivers are just driving randomly from one house to the other without really a careful attention to the route that's taken, then it could increase the collection time, the fuel costs, it could increase the number of trucks that are needed. And so sometimes transportation engineers get involved in the route optimization of waste collection. And some of the factors that are going to influence how many trucks a city would need to buy are going to be things like how much waste per person is being generated. So in society, do people have kind of a minimalist mindset, or are they just consumers who throw away the trash and just don't pay much attention to trying to minimize that impact? The trucks can have a varying compaction density. So the truck itself is going to be trying to reduce the volume occupied by the waste that's being collected, because the more they crush it into a small space in the truck, the less often they have to go to the landfill. And truck volume itself can also vary, as well as how far apart the stops are, how far it is to the landfill. So all of these things are going to be factors that we take into account as we work through today's in-class exercise. And this is the formula that we're going to be using as we go through it. This tells you the volume of waste that is carried by a truck when it's compacted to a certain density of trash. And so V sub T is the number of cubic meters of waste that's carried by the truck to a landfill. And what this is basically accounting for, if you look at all the variables that are in here, we're looking at how many hours per day the waste collection crew is working, the number of trips that they take to the landfill each day. You're taking into account how far it is from the location where they're collecting the trash to either they call it like a sorting station or a tipping yard. Sometimes they don't go all the way to the landfill. Sometimes there's like an intermediate location where they'll dump their trash to be sorted and repacked later, and then they'll go back into the neighborhood and begin collecting again. Taking into account the speed that the truck is driving as it's going, any delays that they may encounter, like traffic delays, the amount of time it takes them to unload the waste, and even takes into account the number of breaks that they have and how long their breaks are. So this is kind of an interesting approach to figuring out like how many, let's see, in this example, we're trying to figure out ultimately the volume of waste that they're collecting for each house they go to, the volume of waste they're taking to the landfill each time they go to the landfill, and then the number of stops that they can, like how many houses they can go to in between trips to the landfill, and then what's going to be the cost. Because some statistics that I found was that operating a landfill could potentially be a pretty lucrative enterprise. Like the companies that take trash get to charge a lot of money for that. They take, on average, across the country, it's $58 a ton is what you have to pay them to be able to take solid waste to a sanitary landfill. If you think about it, what they're really doing is they're digging a pit, they're putting some clay down at the bottom of the pit and some plastic on top of the clay, and then they're just allowing people to bring garbage, and then they're crushing the garbage, trying to compact it. And they're putting a little bit of dirt over the garbage each day. So we're going to start off here in this example defining the variables. And so there's the list of variables here. I'd like you to read through the problem statement and assign the number to the variable for each of them. And then on the back side of the paper is where you're going to determine like the volume per pickup, the compaction ratio, the volume carried by the truck for each trip to the landfill, and so on. So I'll pause. Of course, you're free to interact with each other. You don't have to be quiet as you're working on these in-class exercises. You can check your answers and collaborate and everything. But we'll take a few minutes to go through this and then check the calculations together. Okay, so just setting things up for the equations. Here I've got the variables defined, well, the numbers associated with the variables if you want to double check that.
How did you do average pulse?
The average speed?
Yeah.
I think it's from the figure. So let's see, the distance. Does it say the distance between? Let's see. The total haul distance that they're going round trip would be like about 13 kilometers. And so if they're going 13 kilometers, this suggests that their average haul speed would be, that looks like about 26 kilometers per hour. Okay, so once we get these, we can calculate, for example, the volume of waste collected per pickup. If it's picking up 12 kilograms of material at each house, which has a density of 106 kilograms per cubic meter, then that means it's going to be picking up a volume of 0.1132 cubic meters. And then the trash itself is doing some compaction. So the trash inside the truck is being compacted down to a density of 400 kilograms per cubic meter. So that means that the compaction ratio here is 3.7736. And then the volume of waste, this is the big one, carried to the landfill with each trip. Let me leave this up for a few minutes so you can compare. I've included the units here because I think it's helpful to kind of like visualize and understand what a formula is telling you. There's, on the left-hand side of this equation, or well, the thing that's in front of the brackets, that turns into how many cubic meters per hour is going to be going into the truck. And then inside the brackets is an effective amount of time that you're loading the truck. If you're saying like each trip to the landfill starts off as 4 hours worth of work, but then you're subtracting all of these things out, like the time that they're not taking trash in when they're driving to the landfill. They're not taking the trash in when they're on their break or when they're stuck in traffic. All these things are reducing how much time of the 4 hours is being spent gathering trash. So they can take about 117 stops to the landfill. Because if we are basically saying that, the truck has a certain known volume, then solving for the number of stops tells us it's 117 stops, and then that's less than the 250 per day that's desired. The problem statement initially said that they were going to try and hit 250 houses per day. You wouldn't be able to do it based on how quickly this truck is moving and how long it has to go between places. And then the last part of it, having to do with the cost, is this truck is going to be collecting enough garbage that they have to pay to the landfill $163 per day in tipping fees. So we're out of time. I've actually kept you a minute late, but I'll leave this up for a couple of minutes in case you want to copy it. Remember that we're going to continue talking about landfills in class on Wednesday, but the big thing on your to-do list is getting ready for the presentations next week.